Good morning, my dear students. Today, I am going to take under electrochemistry the next subunit, that is electrodes, cells, and battery. Okay. I am Dr.R.G, Professor of Chemistry, who is taking class for you. Cell and EM of a cell. I already informed you what is an electrode, what is a cell. A cell means automatically consists of two electrodes. Let me define now cell. A cell is a device where electrochemical or electrolytical process are carried out. Please follow. There are two types of cells: electrochemical cells and electrolytical cells. So what are they? One, electrochemical cells and electrolytic cell. Electrochemical cell means will convert chemical energy into electrical energy. Electrolytic cell means electrical energy will be converted into chemical energy. So let me give you in detail. Kindly follow. Electrochemical cell or galvanic cell or voltaic cell, all are named same, will convert chemical energy into electrical energy. Example, Daniel cell. I have already informed you. The zinc rod and zinc sulfate, copper rod and copper sulfate connected by the salt bridge externally by wire by voltmeter. That is Daniel cell. It is electrochemical cell. It is producing electric current. We are measuring with the voltmeter. Kindly follow. So electrolytic cell will convert electrical energy into chemical energy. Please follow. So what I am showing now is a Daniel cell. Kindly follow. Left side, zinc rod, it dipped in zinc sulfate solution. Copper rod dipped in copper sulfate solution. And both these solutions, in order to have contact, a salt bridge was used, a glass apparatus in which a saturated solution of potassium nitrate is used. Kindly follow. Okay, externally these two zinc and metal copper rod are connected by externally wire. So automatically current flows. Kindly follow. Now whenever we say current, there is a difference between physics and chemistry. Please understand this. In chemistry, what we will speak, we will not speak about the current. We will not give importance for current. We will give importance for flow of electrons. So, electron flow from zinc to copper. This is the arrow indicating. Electron flow from zinc to copper. Kindly follow. This is the flow of electron. Whereas the people of physics will say current passes from copper to zinc, they will say. Kindly follow. So we are not worrying about the current, we are worrying only about the flow of electron. So wherever, here kindly follow, this zinc rod by the actual reaction, let me write that reaction. Zinc sulfate dissolving to give zinc sulfate and strong electrolyte sulfate ion. So it will give, now what will happen now? Kindly, the rod is zinc, kindly follow. So here, zinc dissolving to give zinc 2 plus 2 electron is produced. That means oxidation takes place here. Oxidation, removal of electron is called oxidation. So oxidation takes place at the zinc electrode. This is called negative electrode. Why? Electrons are there present in the zinc rod. In the copper ion present in the solutions, they accept these two electrons, so copper will be deposited. Kindly follow. So suppose if you want to conduct an experiment, you take two zinc rod and copper rod and wash properly, dry and weigh accurately. Then again you connect and then you pass electric current. Now what will happen after some times? So you can see here the zinc rod is going on losing its weight, copper rod is going on increasing in weight. Kindly follow. So this is Daniel cell. Let me go for cell and EM of a cell. Cell is made up of two electrodes, namely positive electrode and negative electrode. Oxidation occurs at anode, negative electrode, and reduction occurs at cathode, positive electrode. This is in the case of electrochemical cell. Kindly follow. Let me come for electrode first. I will give some information which is not available in our book. My dear students, this information is not available. Kindly take notes. When a metal is dipped its own ions in the form of electrolytes, an electrode is formed. For example, zinc rod dipped in zinc sulfate solution, copper rod dipped in copper sulfate solution is a specific example. So now there Daniel cell. This I have already explained. Zinc rod dipped in zinc sulfate, copper rod dipped in copper sulfate. The both solution contact to salt breed with the potassium nitrate saturated solution externally by connecting wire, current passes. Kindly follow. Now this is the Daniel cell. Now come for what are the types of electrode. This is not given in our book. Please follow. Kindly take. So you must know the three important information you must know. One is how to represent an electrode, you must know. How to represent an electrode, you must know. Then, how to write equation, single electrode equation, you must know. And from the values of single electrode potential, you must decide which is more positive, which is more negative. Then only you have to form a cell. These three information necessary. Please follow. Let me come for the one first case. The type 1 metal ion electrode. That is zinc in zinc sulfate, copper in copper sulfate, a specific example of metal ion electrode. There is another type called metal amalgam ion electrode. This is normally suitable for alkali metals and alkaline earth metals because they will chemically react with moisture. If you are keeping a rod in moisture, with water it reacts vigorously. For example, sodium, even if you keep outside, it catch fire immediately, reacts with water violently. So what we have to, in order to reduce its activity, we are coating with mercury. That is called amalgamation. Metal amalgamation. Sodium is coated with mercury. Suppose this is the sodium rod. Now we are coated with mercury. So what will happen now? Now the activity of sodium is reduced. Now this will act as a normal electrode. Kindly follow. So, how I can represent this? This is sodium within bracket, mercury, that is sodium plus. Kindly follow, sodium plus. So, when I am writing equation, I will write sodium giving sodium plus 1 electron. This is the equation. Kindly follow. Single electrode equation. Next one, the third and most important is the metal insoluble salt ion electrode. Metal insoluble salt ion electrode. That means you will take a vessel like YouTube and take now mercurous chloride, kindly follow, insoluble salt. Over there is a mercury and you can introduce any platinum, chemically inert rod platinum. So what will happen now? In this case, we have to a known concentration of HCl we have to take here. Known concentration of HCl. Kindly follow. So what will happen now? The correspondingly, this will act as the metal insoluble salt ion electrode. Kindly follow. So here chlorine, mercurous chloride, from this chlorine will goes to 2Cl minus plus the correspondingly Cl2 giving 2Cl minus by accepting 2 electrons. Kindly follow. By accepting 2 electrons, it will go to the 2Cl minus. Kindly follow. So this is called metal insoluble salt ion electrode. Another name is famous name Coulomb electrode. Coulomb electrode. Here the interesting information I want to give. Normally, to form a cell, we need 2 electrodes. So reference electrode, normally the next one is the hydrogen electrode, that is gas electrode. This is the electrode we are using. So what is gas electrode here? Platinum within bracket, that is H2 gas, the atmosphere is 1 atmosphere, bar the concentration of HCl, 2H, that is 2H plus, the molar solution, 1 molar solution. So we will take now HCl solution, 1 molar, and you take a tube, kindly follow in this tube or beaker you can use. Suppose then introduce a rod here, platinum rod. It is coated now, fused. Kindly follow. So here there is a hole through which you can pass hydrogen gas. So the wire now is touching the HCl solution. Kindly follow. So gas is passed at 1 atmospheric pressure and the solution is 1 molar solution. Then only it is called hydrogen electrode. It is called primary standard electrode. But maintaining 1 molar solution and passing 1 atmospheric pressure is very, very difficult. So that's why the scientific world identified a secondary electrode more suitable as this electrode, Coulomb electrode, which is constant, because hydrogen electrode is very, very difficult to construct, whereas Coulomb electrode is a characteristic, it will give an accurate value. So whenever you want to find out any electrode potential, you connect Coulomb to that, depending upon the nature, left or right, then form a cell, and from the cell EMF you can measure with the help of null diffraction potentiometer. Kindly follow. So in the case of hydrogen, kindly follow here, what we can do now, hydrogen gas giving 2H plus 2 electrons. It undergoes oxidation. So here the single electrode potential for hydrogen is 0. Single electrode potential, that is E. I can simply write H2 bar 2H plus, here platinum, this is the representation, comma, that is the 1 M molar solution. 1 M molar solution. This is the representation. I can say 0 at NTP. Kindly follow. So this is value, it is 0. So hydrogen electrode is 0. So by connecting hydrogen electrode to any electrode, it form a cell. So directly you can measure the electrode potential of the particular electrode. Kindly follow. Lastly, I will come for redox electrode. It's another type. That is, we will take a quinhydrone or quinol. This is the quinol. So this will undergo ionization and produce the form of 2H plus. Kindly follow. 2H plus and 2 electrons. Kindly follow. So you take again a tube fused with platinum wire and to which a little pinch of quinhydrone, that is paraquinol powder is added, and that will act as the reducing agent as well as the oxidizing agent. That means redox electrode. Depending upon the nature of other electrodes, it will undergo oxidation or reduction. Oxidation means it will undergo here, the pyroquinol to pyroquinol. Reduction means from here to here. So this is called redox electrode. So by taking any one of these electrode, specifically columnar electrode, normally, and we can connect on any other electrode, we can form a cell. Please follow. Now, UPSC convention to represent a cell. How to represent a cell? What is the IUPAC convention? A single vertical line represents a phase boundary between metal electrode. So if you want to represent a single electrode, zinc bar, zinc 2 plus, this line indicates phase boundary according to IUPAC. This is the electrode representation. Right. In a cell representation, a double vertical line represents the salt bridge, permitting ion flow and preventing the electrolyte from mixing. Kindly follow, mixing. So, kindly see here, Daniel cell example I am taking. Zinc bar, zinc 2 sulfate, double line, copper 2 plus bar copper. This is an electrode, this is an electrode. Here oxidation, here reduction taking place. So in between double line indicates salt bridge. It is filled with saturated potassium nitrate solution. Please follow. This is the convention. Next one, third one. Anode of cell written on the left side. Please follow. Better you should not use anode. So we will say almost whatever undergoes oxidation. Please follow. Whatever undergoes oxidation, that should be on the left side. So generally oxidation at anode. So anode, more positive electrode will be on the left side. More positive will be on the left side. And the cathode of cell is on the right side. So in the canal cell, this is the negative, this is the the oxidation is on the left side, reduction on the right side. So this is more positive, this is less positive. So automatically, so we have to represent this way. Next. The symbol for inert electrode like platinum is often enclosed in a bracket. I have already shown. In the case of hydrogen electrode, within bracket we are writing platinum. Kindly follow. H2 platinum 2H gas. Actually this is not the correct representation. Correct representation is platinum within bracket comma H2 gas 1 atmosphere comma then bar 2H plus within bracket 1 molar. So this is the correct representation of hydrogen electrode. Kindly follow. So here hydrogen electrode oxidation is shown, but here it is used as a reduction when compared to magnesium electrode. Okay. The next one. The value of EMF, electromotive force, EMF, of a cell is written on the right side of the cell diagram. So whenever you are writing the electrode representation, the cell representation, put here now the semicolon, put comma, full stop comma, then E cell you can write here. In this case cell, E cell equal to 1.1 volt. That means a Daniel cell, the voltage is 1.1 volt. Kindly follow. Always the value should be positive. The value should be positive. The negative sign indicates the cell is not feasible. The cell is not feasible. Kindly follow. So let me come for single electrode potential. When a metal is dipped its own ions in the form of electrolyte, a potential arises at the surface of the metal. I told you, you take now zinc sulfate solution. This is zinc rod. So inside there is zinc 2 plus ion will be there. So in the layer, rod and ion, they are in contact. When a metal is dipped its own ion in the form of electrolyte, a potential arises at surface of the metal. Surface of the metal and the ion adsorb automatically. So they are in contact. That potential, we call it as single electrode potential. The tendency of an electrode to lose or gain electron when it is in contact with one ion in solution is called single electrode potential. In this case, zinc is losing electron, that is oxidation electrode. Single electrode is oxidation electrode potential. In the case of copper, it is reduction potential. So I have two types. So let me discuss now. Oxidation potential and reduction potential. The tendency to lose electron means the tendency to get oxidized. This tendency is called oxidation potential. Reduction potential. The tendency to gain electron means the tendency to get reduced. This tendency is called reduction potential. Kindly follow. In the case of Daniel's cell, the oxidation potential for zinc, reduction potential for copper. Now, further information regarding single electrode. It is necessary to mention that oxidation potential is the reverse of reduction potential. Please note, if you know the value of oxidation potential, we know the reduction potential. If you know the reduction potential, we know the opposite, the oxidation potential. Just reverse the sign. Thus, for oxidation potential of the value minus 1.5 volt may be taken as plus 1.5 for reduction. Suppose for oxidation is minus 1.5 volt, reduction will be plus 1.5. Simply change the sign. It is easy. Now it is important point. It is not possible to determine experimentally single electrode potential. I told you already. Single electrode alone we cannot determine the electrode potential. That is, we will call it as single electrode potential, also known as off cell. Off cell. Because two electrodes combine to form a cell means single electrode is called off cell. But after combining these two electrodes to form a cell, we can measure the difference of potential between the electrode, that is cell EMF, electromotive force. With the help of null deflection potentiometer, we can be able to measure. Let me come for standard electrode. By arbitrarily fixing potential of one electrode is 0 for standard electrode, that is reference electrode, usually hydrogen electrode, it is possible to assign numerical values to potential of other various electrodes. So you take hydrogen electrode is the reference electrode or the standard electrode. We know that the value it is 0 plus or minus 0. It may act as an oxidation potential, it may act as a reduction potential depending upon the other the nature of the potential electrode. So by connecting any electrode to hydrogen electrode, we can be able to identify the potential of other various electrodes. Kindly follow me. So in the case of hydrogen, I am now writing PtH2 gas 1 atmosphere bar 2H plus aqueous 1 m molar, that is cell E platinum comma H2 bar 2H plus equal to 0. This is the cell. 0. Standard electrode potential for hydrogen is 0. Now, so that is we have seen already. This is we have shown already. All other electrode potentials measured with respect to standard hydrogen electrode are referred as potentials on the hydrogen scale. Potential on the hydrogen scale. Now, it is not convenient, I told you, it is not convenient to use standard hydrogen electrode as reference electrode because it is very difficult to maintain the activity of H plus ion in the solution at unity. And to keep the pressure of the hydrogen gas uniformly at 1 atmospheric pressure. Very, very difficult. That's why we are not using hydrogen standard electrode. A far better reference electrode is calomal electrode. I told you already what is calomal electrode. So instead of using hydrogen, we are using calomal electrode. What is calomal electrode? So this is the standard electrode we are using. The representation is mercury, mercurous chloride, Cl minus. So this is the E of that particular electrode potential. 0.2422 for saturated potassium chloride solution. Please follow. Inside which we are using potassium chloride, that is saturated solution we are taking. And after the saturated solution, we are adding the paste, mercurous chloride, and then mercury we are adding with the help of again that. So this will act as the calomal electrode. Okay. The potential of calomal electrode on the hydrogen scale has been measured carefully by connecting it to a standard hydrogen electrode. The potential of calomal electrode depends upon the concentration of KCl. For saturated solution value it is 0.2422. So kindly memorize this value. Secondary 0, hydrogen 0, saturated solution of potassium chloride 0.2422. So I want to give for the 3 different value for this calomal electrode. Suppose for saturated solution at 25 degree, I have already given value 0.2422. Suppose for 1 molar potassium chloride solution, the value is higher, 0.2810. 0.1 molar potassium chloride solution at 25 degrees still higher. That means when the concentration increases, the corresponding E value, the concentration decreases, the E value increases. For saturated solution, it's very, very low. So among these 3, this is easy to prepare. Easy to prepare. Kindly follow. How easy to prepare? Because otherwise, the 1m and 0.1m, we by titration, we have to standardize and there may be error will come. But saturated means very, very easily you can prepare. You take a beaker, whatever quantity you want, take 100 ml of water, add a potassium chloride solution, stir it, going on adding. At a particular stage, it will not dissolve, filter. That filtered is called saturated solution. If you measure that EMF, that will be 0.2422. Very, very easy, convenient. So this value you memorize it. Please follow. Now let me come for cell EMF and Gibbs free energy. Kindly follow. Gibbs free energy we have come across already in thermodynamics. Free energy delta G. So now we are connecting this free energy with cell EMF. Kindly follow. Till about the middle of the 19th century, it was generally believed that electrical energy of a reversible cell was equal to enthalpy of the reaction taking place in a cell at constant pressure. That is, E cell equal to delta H. Please follow. It was believed by entire scientific world, chemists believed that before in the middle of 19th century, about the middle of the 19th century, it was believed E cell equal to delta H. But later it was disproved. However, towards the close of 19th century, it was pointed out by Gibbs and instrumentally by Helmholtz, and we have studied already under this Gibbs-Helmholtz equation. Gibbs-Helmholtz equation we have. So, independently by Helmholtz, that electrical energy of a reversible cell is given by free energy degrees of the reaction occurring in the cell. So now E cell equal to not delta H, it is minus delta G. Please follow. This is the very, very interesting information. Previously it was thought that it is delta H, but after 19th century, close of the 19th century, It was now identified by two persons independently, Gibbs and Helmholtz. E cell equal to minus delta G. Kindly follow. For a particular cell reaction, if n is the number of electrons liberated at one electrode, then evidently n Faradays of electricity will be generated in the complete reactor. When n electrons generated means, then n Faradays of electricity will be generated in the complete reactor. 1 Faraday we know, 96,500 coulombs. Will be generated in the complete reactor. For simplicity, EMF of a cell, electromotive force of a cell, is denoted by E cell. Then electrical energy produced by cell is equal to NFE. So let me consider a general reaction. A plus B reversible giving C plus D. So particularly in this reaction, now I can write E cell equal to NFE, N number of electron, F Faraday value is constant, E that is the electromotive force. Electromotive force of the cell. That is the difference between two electrodes. Kindly follow. Now, therefore, I am rewriting now. What way? Minus delta G equal to NFE. E cell both sides constant, so I am writing this. But we know, according to Gibbs-Helmholtz equation, because they have proposed an equation. This is the Gibbs-Helmholtz equation. Please memorize. Minus delta G equal to minus delta H minus T into dou delta G by dou T at constant pressure. This is the Gibbs-Helmholtz equation. So in the Gibbs-Helmholtz equation, now we are going to substitute this value. What way? Kindly find minus delta G I am using NFE. Minus delta H I am keeping as such. Minus T. Now delta G, dou delta G by dou T at constant pressure. I am keeping. So what only I am doing here, instead of minus delta G, I am writing NFE. The next I am doing again, rewriting the equation, everything. Now this minus and this minus into plus. So I am writing plus here. So what are the common factor? N is the common factor, F is the common factor, T is the common factor. I am taking out. So plus NFT within bracket dou E by dou T. E is the electromotive force. So I am getting a new equation. NFE equal to minus delta H plus NFT dou E by dou T at constant pressure. Kindly follow. So this is the equation. Kindly follow. Here N and F are constant. N number of electrons, F Faraday constant for a particular cell. With the help of above equation, what we can calculate? Delta H, delta G, delta S we can calculate. Because in thermodynamics we know delta G equal to delta H minus T delta S. We have arrived. So what we have calculated here? Minus G we know already. We know already this. Delta H we have already calculated. Automatically delta S also can be calculated. Please follow. All the three values we can. Thus, electrical energy NFE is equal or greater than, is equal or greater or lesser than enthalpy depending upon the sign of temperature coefficient. What is temperature coefficient? T into dou E by dou T at constant pressure. T into dou E by dou T at constant pressure is called temperature coefficient. Depending upon this value, NFE is equal or greater or lesser than the enthalpy value. Kindly follow. So it is not always delta H. Originally what we are thinking? NFE equal to delta H. E cell equal to delta H. No. It is not equal. It may be 0 or it may be greater, it may be lesser than delta H. Kindly follow. or so I want to write in the form of equation E. Divide throughout by NF. So I am getting E equal to minus delta H by NF E T dou E by dou T or constant pressure. Kindly follow. This is the another form of equation. This is the we need the cell equation. Kindly follow. Now, number 1. If the temperature coefficient is 0, then NF equal to minus delta H. Kindly follow. NF equal to minus delta H. If the temperature coefficient is greater than 0, then NF is greater than minus delta H. If the temperature coefficient is lesser than 0, then it is lesser than minus delta H. So 3 important conditions you must have it in mind. So I will come for Nernst equation. It is the most important equation for cell as well as an electrode we can derive. Thermodynamic principle can be employed to derive a relationship between electrical energy and chemical energy. I told you electrical energy and chemical energy. For a particular cell, say for example Daniel cell, this is the cell reaction. Zinc plus copper 2 plus giving zinc 2 plus copper. So here I am representing NFE equal to minus delta G. Here N equal to number of electron liberator. In this case 2 electron at an electrode, and N Faraday's NF of electricity will be generated in the equation. Kindly follow. We know from Van 't Hoff isotherm, please remember, Van 't Hoff isotherm minus G, delta G equal to minus delta G0 minus RT ln K, where K is the equilibrium constant. We have already studied under the chemical equilibrium. Equilibrium constant. K is the equilibrium constant. Or I can rewrite now NFE equal to, because I know that minus delta G equal to NFE, so I write minus delta 0 or minus RT ln K. Or NFE equal to NF minus delta 0, I can write NFE0 plus value I can automatically minus RT ln K. What is K? That is the ratio of the concentration of the reactants divided by products. Reactant divided by product. But we know K equal to activity of zinc 2 plus divided by, that is the product. I will follow here. I will write the equation, then you can understand. Zinc plus copper 2 plus giving zinc 2 plus copper. This is the product, this is the reactants. So ratio K equal to product zinc 2 plus into copper divided by zinc into copper 2 plus. This is the K value. Kindly follow. So actually, this is actually in terms of concentration term you are using, but actually strict rule is activity of the rod we have to use, single electrode potential, activity. That's the difference between activity and concentration. There is difference. So here activity of zinc 2 plus into activity of copper, that is product, divided by activity of zinc divided by activity of copper 2 plus, that is K value. So now I am substituting this value, I am getting this equation. NFE equal to NFE0 minus RT ln A is the 2 plus into A is Cu divided by A is the 10 into A Cu2 plus. Or I am dividing throughout by NF. I am dividing throughout by NF. What is happening now when I divide? So here when I divide NF, cancel E. Here NF, cancel here. Here, so E equal to E naught minus RT by NF. RT by NF, Ln, activity of zinc 2 plus into activity of copper bar, activity of zinc into activity of copper 2 plus. Please follow, this is the most important. For approximations, replacing activity terms by concentration terms, we will write instead of activity concentration. Actually, activity equal to concentration into activity coefficient. Activity equal to concentration into activity coefficient. But for approximately, since the value is the negligible value, so we are for approximation replacing activity term by concentration terms. We write now E equal to E minus E0 minus RT by N of ln, that is Zn 2 plus bar Ce 2 plus, because activity of copper, activity of zinc is nothing but 0. So the ln means nothing but 2.303 log. So I am now using the term E equal to E0 minus 2.303 RT by N of log zinc 2 plus by copper 2 plus. Or finally I am writing E equal to E0 minus, so by substituting the value of R and the temperature and N, that is the F value, and 2.3, everything I will put, I calculate the value, it is 0.059. This should be memorized. 0.0591, it is memorized. So E equal to E0 minus 0.0591 by N. Why we are keeping N? Depending upon the electrode oxidation, 1 electron, 2 electron, N will vary, so that we are not changing. So log is the concentration of product by concentration of the reactant. So in this equation, 5, 6, 7, 8 are called Nernst equations for a cell. Kindly follow. So whenever it's a derived Nernst equation, means this is the Nernst equation, final one. Kindly follow. So now Nernst equation for a half cell or single electrode I can give. This is undergoing oxidation. So according to oxidation, what I will write? E m bar Mn2 plus gives E0 m by Mn bar by Mn2 plus minus 0.591 by N log Mn plus, because this is on the right hand side. So for oxidation, it is log Mn plus. Here, this is the Nernst equation for single electrode, that is for oxidation at 25 degrees centigrade. For reduction, I can show you now. So Mn2 plus N electron, that is copper 2 plus 2 electron copper, like this, giving M. For this general, I am using now Nernst equation E Mn2 plus here bar M, kindly follow, then E0 Mn plus bar M minus 0.0591 divided by N log 1 by Mn2 plus. This is 1 below is coming now. In the case of oxidation, the concentration term comes below denominator. In the case of the reduction, in the case of oxidation, it is at the numerator. Please follow. So this is the Nernst equation for single electrode potential. Now I want to give one important information before concluding the chapter. My dear student, kindly follow. So normally in your book, they will give standard electrode potential series will be given. Starting from fluorine, and this is the reduction potential. Please follow. Reduction means metal N plus N electrons giving M. This is the reduction. So this is the reduction potential given. So starting from fluorine plus 2.87, it is going on. Now kindly follow. Now the count for here, there is hydrogen is here. Kindly follow now. Here there is hydrogen. This is the standard hydrogen 0. So above the hydrogen, copper, silver and gold normally will use. So these electrodes normally it is below 0. Kindly follow. That is positive value is greater than value. Reduction potential is greater. Whereas below the hydrogen, kindly see all the reduction potential are negative values. Kindly follow. The lithium is the highest negative. Kindly follow. So this way you have to remember this. So let me raise a question now. So how to, suppose we are giving two electrode, they are giving. How to connect the electrode, either left or right, which electrode we have to connect. Even in physics people, physics students, physics teacher may not know this clear idea, they will not give. I can give you a very clear idea. Generally, first group and second group metal, alkali and alkaline earth metals, they are more positive, easily undergo oxidation. Easily undergo oxidation. So always oxidation at the left side. Oxidation at the left side. So what you can say, potassium or whatever it is, with the metals, all potassium sodium means you have to amalgamate, you have to use. So let me say calcium bar, calcium 2 plus. So this should be always left side. Kindly follow. Reduction potential means automatically the less negative metal. This is more positive. When you move across the period, the metals are coming. That is, this is S block elements. Go for D block and the B block elements. They are less positive. So that electrode comes should be on the right hand side. So this is the way you have to memorize, my dear students. So easy way you can write. So for example, why we are writing zinc left side? Kindly follow. Zinc bar, zinc 2 plus, double line, copper 2 plus bar copper. Why we are writing? Kindly see here. Come over here. This is zinc here. Zinc is here. Zinc is the lower negative value. Okay. Whereas that is copper is there in the above hydrogen. So when you compare zinc and copper, the zinc will undergo easily oxidation. So instead of that, better, my idea, we will always remember the oxidation potential value rather than reduction potential. Because, so if it is oxidation potential, this will be 0.76. 0.76 minus the chlorine, this value, copper value, kindly see, this is plus, so it will be plus 3.34. Plus 0.34, so it will be minus, kindly follow. So zinc is 0.76, kindly follow, that is minus 0.34. This is oxidation potential value for these two, zinc and copper. Kindly follow. So here, which is more positive? Left side, positive. So that should be always left side. Right side should be copper. So we can easily decide, when you form a cell, which side you have to connect positive electrode, left side, negative electrode on the right hand side. So oxidation at the left side, reduction at the right side. Kindly follow. Now, one more important information I want to give here. For example, cell representation here, there is cell. So at anode, this is the cell reaction. At cathode, this is the cell reaction. Oxidation, this is reduction. This is the overall reaction. This is the overall representation. Kindly follow. You must know how to represent the cell. You must know how to represent overall reaction. You must know the single electrode potential and single electrode for oxidation and reduction. Now, the most important information I want to give here, my dear students. Let me take now zinc and copper. The oxidation potential 0.76, reduction potential 0.34. Then reduction potential, this is minus 0.76, this is plus 0.34. Please follow this. I have noted from the reduction potential series. So I told you always follow the oxidation potential. It will be easy because then we can decide whatever the more positive metal you can keep, because how we can easily identify from the periodic table. Value we cannot memorize. Value we cannot memorize. What we can memorize? The position of the metal can be memorized. That's why I am suggesting this idea. So, for example, there are two methods we can calculate cell EMF. The first method is E cell equal to E oxidation minus E reduction. Kindly follow. E oxidation minus E reduction. So in this case, please follow, my dear students. A lot of confusion will come and many teachers will confuse you. Don't confuse yourself. You follow my technique. First you take cell 1, first one, equation. E equal to E oxidation minus E reduction. So that you use both cases oxidation potential value. Both cases oxidation potential value. What I am going to write now? 0.76 minus 0.34. Kindly follow. This is the first one. Oxidation potential value for zinc 0.76. Oxidation potential for copper minus 3.4. So minus into minus plus, it is 1.1 volt. Answer is 1.1 volt. Kindly follow. Let me come back the other one. Kindly follow. The second method is E cell equal to E oxidation plus E reduction. Plus E reduction. In that case, here you have to use E oxidation value. Here you have to use E reduction value. So what is E cell? E oxidation 0.76, E reduction 0.34, add again 1.1. So both cases the value is same. So whatever method is, it is easy to you remember. So for me, I am following from my BSc onwards. Only this is I am following because E cell equal to E oxidation minus E reduction. Only oxidation value I will use. So that way. So but this is option to you. You can follow whatever method you. So use oxidation potential for oxidation and reduction potential for reduction. Okay. So we have come to the conclusion, my dear students. So thank you very much for your kind cooperation given so far. And if you are coming for the first time to my channel, Neat Chemistry by Dr.R.G, please click and please subscribe to motivate me. And this is the channel, you can share it to your friends, telling that this is the chapter taken from 8th standard to 12th standard. And after finishing these question papers, these chapters, I will, each unit, I will discuss the previous question papers. What way? I will give first priority NEET, second priority IIT, third priority AIMS, fourth priority AIPMT, fifth priority the MSET Andhra. So I hope I will take 5 questions, 10 questions from each one I will take from the previous question paper. I will discuss. So that, just imagine, we are having nearly 30 units are there in chemistry. 30 units into, just you multiply 30 into 45 questions. So 50, 40, 12. So 1350 questions will be there. Video questions will be, I will be discussing. Kindly see. Please. So that is the most important. It is more important. Please follow. Okay. Dear students who are waiting for NEET and an examination for Government of India, that is studying +1, +2 and +2 completed students. So for you, I am having a good news. We are running a coaching center, Vetri Coaching Center in Pondicherry, but people from outside cannot come and join. And in this path of the pandemic condition, so we have a very good website, Vetri.s. So we are running for the 21 years the Vetri Coaching Center, and we have a lot of achievement in this. If you want to see, view the achievement, enter the home page and see all evidences given in the home page. 1 or 2 evidence I want to indicate. Number 1, we are sending minimum 15 to 20 students every year to JIPMER, 150 to 200 students to other medical colleges of Pondicherry, and more than hundreds of students are going to medical engineering colleges. A few students are joining IIT Madras. And the most important information, in 2003 itself, a person, R. Srinivasa Raghavan from Patrick School, came All India first rank in JIPMER. At that time, NEET was not there. All centers will have separate examination. So this is our merit. So let me give the importance of ventilators. 3 important features of ventilators. One is, in ventilators, if you open, you have 200 video lesson, 200 unit test. Unit test you have. 200 video lesson and 200 video test. That unit test is there. Kindly follow. The video lessons were recorded by the professors having PhD degree and 20 to 30 years of experience handled the classes. And when we are viewing the classes, there is a facility you can touch and immediately it will stop. You can note formula, definition, equation, different everything, column, table, column, diagram, everything. Then allow touch again, it will run. So any number of times you can see the video. Another most important, 200 unit tests we are giving. Say for example, this is the electrochemistry. In the electrochemistry, I am giving 2 tests. Test 1, test 2. Each one having 45 questions. Each one having 45. That means each unit having 90 questions. So all these questions are taken from 20 years of IIT, AIIMS, AFMC, AIPMT, MSET Andhra, Karnataka, Kerala, Delhi, Tamil Nadu, Pondicherry question papers. You can ask me, what is the advantage of giving the previous year question paper in the unit test? Because we are giving training to students, so when they are attending, they will do mistake, they will see the video solution, and by practice, they will become slowly increasing the marks. So the one most important is, we have observed for the last 6 years in the NEET, 75 to 80 questions, same questions are repeated. Same question from our question bank, same questions are repeated. Suppose if you are able to attend all 200 tests, if you have written all 200 tests, minimum 400 marks with you. Minimum 400 marks you will get. Additionally, if you are a good student and hard-working sincere, you will get minimum 300. So automatically, you will get 700 marks. Kindly follow. Easily will get 700. So even dull students, they can go up to 500 to 600 if you go for ventilators. Now, I will point out one more importance. When you are attending our test, kindly follow the unit test, there is a menu called attempt. You click attempt, a window will open. In the window, question 1 will be seen. Option A, option B, option C, D. There are 3 menus are there. And below there is a question number 1 to 45 questions in yellow color. This is you can see when you see attempt. Kindly follow. And also it will indicate you this unit contains 45 questions, correct answer 4 marks, the wrong answer -1, everything it will give. So our program, it is the ventilators is programmed in such a way that it will do automatically correction. For correct answer, it will add 4, wrong answer, it will subtract minus. This facility is not available in other online coaching center. Kindly follow. Suppose if you click A, assuming it is correct answer, what is the wonder you can see here? Immediately below 1 to 45 yellow color, that yellow color 1 will change into green color. That means you have attended 1. The second 2 will become blue color, all other will be yellow color. Kindly follow. So the 3 menu below, center is complete. This is only press after completion of the 45 question in Vetti.S, 200 question in Government of India. The next is, this is the next menu. This is the reverse menu. So next, if you click second question, reverse if you click, go to the previous one. Okay. So here I want to give one important information for students who are going for All India Entrance Examination. Kindly follow. 3 steps you have to follow. If you want to get 600 to 700 marks, definitely you have to follow the 3 steps. What you have to follow? You attend this order: botany, zoology, chemistry, physics. This order you have to attend. First step, step 1, only known questions. 100% known question, put a tick mark, tick mark, tick mark, tick mark. Only theory questions. So approximately, let me say, even botany and zoology, there will be 50-50, 100 questions will be there. Chemistry, physics, there will be 50. So nearly 150 questions will be minimum theory question will be there. Minimum 150 question theory, 150 to 200 question minimum will be there. Kindly follow. That is, kindly follow. This is 50. Kindly follow. This is 50, 50, 50 means total is 200 question. Out of 200, botany and zoology to 100, already 100, only theory. Coming for physics, chemistry problem, so I can say 50%, so I will take 50. So I will take now 150 theory questions. Kindly follow. 150 theory question means, so let us assume 100 question is known to you. Well, 100 question known, simple, multiplied by 400 marks you are getting. So, through Vetti, I told you already 300 question, known question repeated, so already you are sure about 400. So, 400 marks, it is sure. Then, second step we can go, start from botany, zoology, chemistry, physics, a theoretical question which is very difficult to answer. Difficult question, theory question. Think twice, thrice. And if you come to conclusion it is 80% valid, put a tick mark. If it is less than 40% valid, don't answer the questions. Step 2 over. Third step, go to the problem. The chemistry and physics. So comparatively physics will have more problem than chemistry. So attend the problems, substitute the suitable formula, substitute suitable units, multiply, divide, everything, find out the answer and compare with this option given in the question. If the answer is correct, put a tick mark. If answer is not correct, don't correct. So when you answer like this, so approximately out of 200 questions, you can be able to answer minimum 150 questions you can answer. Now, I am telling minimum 150. Minimum 150 means 600 marks guarantee for you. 600 minimum guarantee. So you can get, if you are a good student, 600 to 700 you can get. So you will become All India rank. You can go join JIPMER or AIMS or Vellore, any medical college you can join. Please follow. This is the way you have to follow. Now coming for our Vetti.S, training you to attend All India Entrance Examinations. After attending all the questions, click complete. When you click complete, immediately here we are having option, you will get a marks, for example, 160 by 180, because 45 questions we are giving, 45 into 4, 180. So 160 by 180 means 4 questions you have done wrong. Can you follow? You want to know which question you have done mistake. There is provision. Please follow this provision. It's not there in Vetti.S. Kindly follow. Previous year question is not given in any other online coaching. We are giving. If you want, you verify. You take any question, go to the corresponding question paper, unit wise, then it will be available. Next, The coming for the next is a review. You now click review. A menu is there. A window will open. Click review. A window will open. In the question 1 will there option A, option B, option C, option D. Correct answer also will be given in yellow color, and below that there is a video solution. Video solution will be there. Kindly follow. When you click review, question 1 you can see. If you have clicked A is the correct answer, it will be in blue color. Please follow. Your answer will be always in blue color. Correct answer will be always in yellow color. You can able to identify. You can compare these two. So you can identify which case you are doing mistake, which case you are doing correctly. Okay. Suppose you are having controversy, you do not know the answer, please follow. There is a video solution. Please follow. This facility is not available in any other online coaching because they are giving just one word or one line answer. But we are giving a video, 10 to 15 minutes video solution. The professor, concerned professors with a doctorate degree and 20 to 30 years of experience will read the questions and inform you from which topic it is asked, what are the options, and they will, if it is a problem, what is the formula you have to apply, how it is work, everything they will give, definition, equation, everything they will inform right on the board. Even a very dull student, poor student, they can easily understand. So if you can, even a dull student, if you are able to write 200 tests, minimum you can get 500 marks, I will give you guarantee. If you are a brilliant student, definitely you will get 700 marks. So it is the easy method. So join with your doctors to become a doctor. The most important among them all is the low cost. So it is not a costlier. All other online coachings are charging lakhs. We are charging only 10,000 per year. 10,000 only per year. Kindly follow. How to pay these 10,000 rupees? Pay in the name of Santi, Director Vetri Coaching Center. Account Indian Bank account number 71271947, IFC code Kamarai Salai, Pondicherry, ID IB 000P134. And after paying, if you want to contact to get the secret number, that is contact my cell number 989417645. Any query if you want, contact me, Professor Dr.R.G 989417645. Thank you very much. See you again in the next chapter.